Kathy Malerba, Associate Director for Research and Evaluation in Round Rock ISD.
I'm Megan Olszewski, Coordinator for Research and Evaluation.
In this video, we'll discuss two simple growth models and the STAR progress measure. We'll also talk a bit about the similarities and differences of these measures. Let's get started.
No matter how you decide to measure growth, you must always start with a valid and reliable assessment. A valid assessment is one that measures what it says it measures. If I want to assess learning in 8th grade math, then the items on the test must reflect the content of the 8th grade math curriculum. A reliable assessment is one that measures learning in the same way over time or across people. If I give the same algebra test to two students who have the same level of knowledge, they should score approximately the same on that test. The most basic growth measure is simply a difference score or gain score. Let's say we give Taylor and Emily the same valid and reliable writing assessment at the beginning of the year, and they both earn 3 points. Then, at the end of the year, both students take the test again. Taylor scores an 8 and Emily scores a 6. Because Taylor's gain score is higher, we can say she had more growth in her learning than Emily. The gain score does not tell us why Taylor scored more than Emily, but it suggests that we might want to dig more deeply into which concepts they understood and which ones they're still struggling with.
Now let's talk about another simple growth model that's often called a value-added model. Value-added models are based on linear regression. These models can be quite complex, particularly if you need your calculation to account for student demographic factors, teacher or school factors, or measurement error, but at heart they all examine the linear relationship between sets of test scores. We use these models to identify teachers or schools who add value by helping students grow more than expected from one year to the next. In our example, we're going to look at a subset of 4th and 5th grade math STAR scores. Unlike our simple pre-test, post-test example, psychometricians have designed these two tests to be comparable across grade levels. Notice that across the x-axis is the range of scores at 4th grade, and across the y-axis is the range of scores at 5th grade. This scatter plot is a graph of all the individual students' 4th and 5th grade test scores. The regression analysis produces an equation that is the line of best fit, which means it's the line that best describes the relationship between 4th grade scores and 5th grade scores across all of these students. In a basic regression equation, we can use the time 1 score, the point at which the line crosses the y-axis, and the slope of the line of the best fit to predict a 5th grade score for any student. This information also lets us talk about the difference between students' predicted and actual growth. For example, Michael scored 3291 in 4th grade and 2900 in 5th grade, so he has a lower than expected growth based on the distance between his actual score and the score that's predicted by this linear equation. Alex scored 2900 in 4th grade and 3395 in 5th grade, so he has higher than expected growth as indicated by the large distance between his predicted score and his actual score. Notice that I'm using the word predicted in a different way than I would in everyday speech. This equation does not allow us to predict anything about student performance next year in 6th grade. The equation is based entirely on the observed scores of these students in 4th and 5th grade. We could cautiously use these scores to estimate how last year's 4th graders will do on the 5th grade test this year, but we know nothing about possible performance of these students next year. We also know nothing about why Michael and Alex scored the way that they did. Alex's growth could be related to a tutoring program he attended, but this example doesn't include that context. Knowing a student's scale score and level of actual versus predicted growth should be the starting place for your inquiry about that student. A typical next step is to look at student performance on certain TEKS to see what learning objectives the student has mastered and which ones they're still struggling with. Each of these little dots is a person with unique interests, motivations, and strengths. And if you want to help a student grow in their learning, there's no substitute for getting to know that student well as an individual.
The last growth measure we will discuss is the one TEA uses to determine a student's STAR progress measure. Calculating the progress measure is a hybrid approach looking at growth from year to year. It's based on a gain score, but it's also based on the psychometric work that determine the STAR passing standards. We will be discussing only the GAIN score part of this work today. To determine if a student did not meet progress, met progress, or exceeded progress, you have to know the student's current year STAR raw score, STAR scale scores from the current and prior year, and you have to use the TEA provided chart to determine if the year-to-year GAIN score is large enough to have met progress. Let's work through an example calculating the TEA progress measure for Nicole, a 4th grade student who passed the math test in 3rd grade and who took the regular English version of the Math STAR in both grade levels. The first thing we do is look at her raw score. If it's no higher than if she had guessed on every item, then she automatically would not meet progress. If she earned one of the 3 highest possible scores, then she would automatically exceed progress. Nicole had a raw score of 39, which is between these two extremes, so we must look at the points TEA says are necessary to meet expected growth. The needed GAIN score is greater than or equal to the difference between the final Level 2 passing standard in 3rd grade, 1529 points, and the final Level 2 passing standard in 4th grade, 1599 points. That difference is 70 points. To exceed progress, Nicole would have to have a GAIN score greater than or equal to the difference between the final Level 2 standard in 3rd grade and the Level 3 standard in 4th grade, which is 1677. That difference is 148 points. Nicole scores a 1501 in 3rd grade and a 1599 in 4th grade, which is a gain of 98 points. That is more than 70 but less than 148, so Nicole met progress. Notice that with the TEA measure, once we weed out the extremely high and extremely low scores, what matters is the absolute number of points gained, not exactly where the student started or where they ended up. This is good news for students who may have failed math in 3rd grade because they can meet expected progress as long as they gain 70 or more points in 4th grade.
Let's take a moment to compare the simple value-added model to the TEA progress measure. The similarities include that both are based on STAR scores, that the growth analysis is limited to grade levels and subject areas tested on STAR, and that students typically must take the same test in the same language and version in both years to be part of the analysis. Some of the differences include that a value-added measure is the comparison of predicted versus actual scores. The passing standards are not needed or relevant to the calculation. In contrast, the STAR progress measure is tied to points gained between the final Level 2 passing standards from one year to the next. The value-added equation is based on the performance of a group of students relative to one another. There will always be students who grew more or less relative to their peers. With the STAR progress measure, all students have an opportunity to meet expected growth. Meeting progress is tied to point gains from year to year. It's not tied to the performance of other students. With value-added measures, districts have more control over the calculations, so they are useful for examining student progress in the context of a program evaluation or to calculate growth for performance pay. However, the STAR progress measure is an important part of the state accountability system. It is the basis of Index 2 student progress. Well, we're coming to the end of our time together. We hope you've learned that there are different ways of measuring student growth, and you should choose the appropriate growth model based on your needs. If you'd like to know more, Battelle for Kids has produced an excellent resource for school administrators. One final thought. There is a point of diminishing returns when you use the same sets of scores over and over again in slightly different ways. Ultimately, if you want to look at growth in new ways, you will need to measure learning and growth in learning in new ways too.
As always, you're welcome to call our department with your questions. Thanks for watching, and thank you for your interest in measuring student growth.